Welcome, ladies and gentlemen, to the group exhibit Hydrogen Fuel Cells and Batteries, here to our public forum. We have a panel discussion here now for the next 40 minutes, and I'm very happy to see you all here interested in participating in this discussion. So whenever you have a question, just raise your hand. It will be all about the hydrogen and fuel cell activities in the United States of America and in Europe. So we have very high-ranking speakers here on stage, so I'm very happy to introduce to you right next to me, Dr. Sunita Satyapal. She's Director of the Fuel Cell Technologies Office within the Office of Energy Efficiency and Renewable Energy of the United States Department of Energy. Good to have you here, Sunita.
Thank you.
And I would like to welcome Philippe Vannson. He's Executive Director of Fuel Cells and Hydrogen Joint Undertaking, coming directly from Brussels to us. Welcome to our stage here. I would like to welcome also Dr. Graham Cooley. He is CEO of ITM Power, an exhibitor here just right next to our public forum, and also another exhibitor coming from the United States, Brian Cheadle, Director Global Business Development of Dana Holding Corporation. His booth is also seen over in that direction. So we have well, two manufacturers actually, and we have two people from the policies, so it's going to be an interesting discussion. So whenever you want to participate, just raise your hand. Sunita, let us start with an interview I've read where you said, "The most fulfilling aspect of my career has been influencing the course of progress of the entire research and development community in the field of energy through our work at DOE." What do you think? What progress has R&D community done in the field of energy during the last years?
Well, thanks for the question. First of all, thank you for the invitation. It's great to see all the hydrogen and fuel cell community here. And as I mentioned yesterday, it's such an exciting time. So after years of research and development, we actually have commercial fuel cell vehicles on the roads today. And if you look at the work that we've been funding over the years, it started in the mid-1970s after the first oil crisis. A group of researchers, government, industry got together at Los Alamos National Lab to really look at what are options to completely eliminate petroleum dependence. And later on, they developed the foundational MEA optimization technology, taught researchers from around the world. Eventually, General Motors actually relocated to Los Alamos, and that helped spur the inception of the DOE program. And so we've seen huge progress. There are many examples, but just to give you a couple, reducing the cost of fuel cells 80%, reducing the amount of platinum.
Most important one, probably, yes.
And even on the electrolyzer side, reducing the capital cost 80%, increasing durability a factor of 4. So I think it's hard. So many people have been in this community for so long. I think it's important to step back and really look at all the progress, the fact that it's becoming cost competitive, performance is good. We actually have now some of the early markets, forklifts, backup power in the US, major companies, FedEx, Walmart placed an order of 1,000 forklifts, Coca-Cola using fuel cell forklifts, Sprint with backup power for telecom, so thousands of units now in the field. These are commercial units. So I think it's very, very exciting.
So you're spending around $100 million each year for research, development, yes, even also in deployment and demonstration projects in the United States. So these $100 million are well spent in the last years, what you would say?
Yes, about 80% of our annual budget of about $100 million per year is still the research and development. So about 20% is more cross-cutting, so safety codes and standards, demonstrations, really enabling the early market. But again, we do think that significant R&D innovation is still required, so we're sustaining that effort. I would say there are about 580 patents as a result of the recent work, and about 40 commercial technologies that are in the market. And then we also see another about 65 technologies that we think will be commercial in the next 3 to 5 years. And so the companies or other organizations specifically trace that success back to the government funding, the DOE funding. So it's been very rewarding.
Mr. Cheadle, or you can't say Brian maybe because you all talk American, you know, Brian. Dana is an automotive component manufacturer founded in 1904 already, and you serve the automotive industry as a supplier. You've been a little bit pushed into this field of technology of fuel cells by a car manufacturer, as far as I know. Is that right?
I would say it's more of a market pull. We've seen we've been involved in, as an extension of our traditional business, selling automotive components. We've been involved for quite a few years in looking at how to apply those to the future fuel cell vehicle market. So we are working with a number of OEM car companies, and we look at them as market pull for us to develop the right components that are needed to help commercialize those vehicles.
Okay, so was it GM who pulled you in? If you say it was a market pull when they went to Los Alamos, or what, who was it?
I don't think we go back that far. As a tier 1 supplier to the automotive companies, generally we don't name them. It's part of a standard business practice. So until we get to production parts.
So Brian, when you had a lot of work developing your fuel cells for the automotive industry. You were pretty successful actually in durability and cost issues. But still, if you look at fuel cell cars, it's not GM, it's not Ford who's coming to market. It's Toyota, it's Hyundai, it's Honda. Are you a little bit disappointed?
Well, we operate in a global environment. We have good customers around the world, so in a way it's not so big a concern. We like to see the North American market develop, we'd like to see the European market develop, but we find business opportunities wherever.
So you're also working together with Toyota and Hyundai and you
perhaps.
Obviously don't want to talk about it, frankly, so we just be ready that you have the products for all auto manufacturers. All right, Philippe, so I just mentioned that they didn't come from GM, not from Ford and not from Chrysler, but as well not from Daimler and not from Fiat or Renault. So again, the same question to you. Are you a little bit disappointed with the car manufacturers in Europe?
I must say we are waiting for European brands to be on streets.
Long years.
Because I mean, I'm an official of the Commission, and we are in continuous conversation with our masters, the Council of Ministers and the Parliament. And reports are nice, promises are very nice, but we need to see hydrogen solutions on streets. I mean, convincing our authorities to set aside 680 million euro for financing research and demonstration in fuel cells and hydrogen is quite a challenge. People need to see to believe. And for example, we have also plans to finance hydrogen refueling stations. We would love them to be used by European cars as well.
Philippe, the Fuel Cell and Hydrogen Joint Undertaking is a public-private partnership supporting research, technological development and demonstration activities in fuel cell and hydrogen energy technologies in Europe. So you have, if you count together, 3 members, the European Commission, you have the industry, and you have the research community. It's sometimes pretty hard to get them all together, isn't it?
No, I mean, it's the beauty of this partnership, I would say.
You find it beautiful, okay.
I would. It's the beauty of that. You cannot do industrial research without industry and without research. And it's really this fruitful cooperation, collaboration that helps defining a vision. What is good also in this type of arrangement is that it provides for long-term vision. We have, compared to other programs, a multi-annual planning that is possible. And in these times, it's really extremely important for the stakeholders to develop their business.
That's nice. You don't have to convince the Congress for every other million you need, like Sunita probably has to do.
Yeah, we do. We have a budgetary procedure every year, but nevertheless, we have a framework that is robust enough to be useful.
Let's talk a little bit about this framework. The old framework was the framework program number 7,
Yeah.
and now we have Horizon 2020. There are still programs running under framework program 7, and 30 new programs now under Horizon 2020. Just tell me the highlights.
The highlight of what? Of Horizon 2020? I mean, it's covering all the scopes of technologies, but I would say that the current FCH2 joint undertaking is fully in line with, or at least its objectives are fully in line with the objectives of the Energy Union, meaning providing for sustainable solutions, increasing the security of supply, boosting the economy, and also locally providing for solutions that are acceptable in towns and cities.
You didn't mention any highlights yet. It's just a general perspective.
It's a general framework. We see, over, as Sunita said, over a shorter time period, because I'm involved in this venture since 2000. I've been involved since 2008. But I can tell you that coming back, since I'm back since 1st of January, I see a lot of progress that has been achieved. I see conferences attended by many people. Look around you. There are plenty of new things to be seen. And we would love to see more solutions. We would love to see refueling stations to be able to tank our own hydrogen car.
I have learned Sunita can spend $100 million per year. How much can you spend annually?
Well, more or less. We have 680 million
for the next 7 years.
7 years. Yeah.
Well, okay, almost the same. Yeah. Very good. Graham, as a manufacturer of electrolyzers, you probably think about the hydrogen infrastructure as well. It's an important issue for you because you can provide hydrogen refueling stations with on-site hydrogen production, and if needed, even 100% from 100% renewables, can't you?
Yeah, absolutely. So we're building 8 new refueling stations in the UK right now. They'll be launched this year. Actually, most of them are funded by the FCHJU, which is one of Philippe's highlights, of course, that you asked for. We make electrolyzers that produce hydrogen on site, so there's no carbon footprint in the production using reforming, and there's no transportation. So we connect directly to renewable power. We actually have an electrolyzer that will turn on and off in less than a second. So it's useful for grid balancing.
I've just heard from Simon, he was talking about that one, yes.
So the two unique things about ITM are the electrolyzer can respond in less than a second to a signal from the grid company. That gives you grid balancing. We also make hydrogen at high pressure, so you need less storage. So many applications, having a 50 bar, for instance, it reduces your overall costs.
So really the electrolyzer industry is developing very quickly during the last years, we could really say.
Yeah.
And what else we could say, you not only have projects in Europe, but also in the United States. I know of a high-pressure electrolyzer in Hyundai's technical center in California.
Yeah, Yeah, so there are three very important territories for us. One is our home territory, of course. The other one is California, where the Californian Energy Commission are backing the rollout of hydrogen refueling stations. And for power to gas, which is a larger scale application where you put the hydrogen directly into the gas grid, Germany is a very important market. And we've just sold another 1 megawatt unit into Germany and a number of others coming forwards now. So that's very important for us as well. California is a very important territory for hydrogen. Californian Energy Commission completely committed to the rollout of hydrogen. It's even ingrained in law now in the US, the number of refueling stations that will be rolled out to 2020. And all the car companies, as you know, are rolling their vehicles out in California, in the UK and in Germany.
In the UK, your home country, you just signed a contract with Toyota, a Japanese manufacturer. So it seems to me the business is quite global, isn't it?
It is,
like also Brian already said, yeah?
So for us, for deals, we just announced a tie-up with BOC Linde to make the dispensers. We have a siting agreement with Shell to put our refueling stations on their forecourts. We have agreements with National Grid to do grid balancing, to make lowest cost, lowest carbon hydrogen, and a fuel deal with Toyota. So things are going well. You ask whether everyone was disappointed with the car companies in the US and Europe. I am a bit disappointed with them. We have the Toyota vehicle, the Hyundai vehicle, and now the Honda vehicle. But it's not as simple as that, actually, because of the tie-ups between General Motors and Honda, between Toyota and BMW. And those deals in the background are another way of looking at the way the industry is developing.
But for me, a little bit is like history repeating, Brian. When I had this hybrid boom when Toyota came to market, and everybody said, "Oh, come on, hybrid! Nobody needs hybrid," and then everybody was buying it, especially the VIPs from the United States. And then these corporations started. Are you expecting these corporations also after the first years of Toyota's Mirai and Hyundai's Tucson?
Well, I think going back to the start of hybrid vehicles that you speak of, it's important to realize that many of the electrical drive systems are common to battery cars and fuel cell cars. So it really isn't so much a competition between them as rather an interdependent evolution. So hybrids, fuel cells, hybrids back and forth. Fuel cells will serve as power plants for the entire car. They may also be used as range extenders in conjunctions with batteries. So there's a lot of interdependence.
I would like to open this discussion to everyone. Whoever wants to ask a question, just raise your hand. Be with the microphone right with you. Don't be shy. Everybody can participate here in this discussion. So, Sunita, I would like to focus a little bit about the differences also between Europe and the United States, especially California, as Graham already pointed out, is a very important market for him, and not because California is so beautiful, but California has this low emission program, which helps very much. By the year 2018, at least 18% of all newly registered cars in California must be zero-emission vehicles. I think that helps fuel cell cars very much, and that even helped to bring the Mirai to California. Don't you think so?
Right, definitely. So I would say that California, I think, as many of you know, is a major force in the U.S., the 8th largest economy in the world, basically, and a major driver has been the ZEV mandate, so the zero-emission vehicle mandate, 1.5 million vehicles by 2025. But I should mention that 8 states, there was an MOU signed, mostly northeastern states, but also Oregon, a few other states, that committed to 3.3 million ZEVs, zero-emission vehicles, by 2025. So we have that. We also have the federal, the CAFE, the Corporate Average Fuel Economy Standards in the U.S. So there, the requirement is 55, an average of 55 miles, roughly miles per gallon by 2025. So you have the ZEV mandate, the fuel economy targets, and then you also have emissions in terms of criteria pollutants and air quality, California. So with the California Energy Commission basically commitment to 100 stations. By 2023, there's definitely strong support for hydrogen, but I should say there's support for the portfolio of technologies. So
yeah,
it
needs
not
to be
only
zero
hydrogen.
emission vehicles.
Right.
So
Right.
that could be the Teslas. They're selling like fresh bread, we say in German.
And actually, the U.S. just surpassed, I think it's 410,000 electric vehicles. So far, if you look at EVs, the plug-in electric vehicle, not the fuel cell electric vehicle, I think commercially it's surpassed a million worldwide, and 410,000 now in the U.S. So there's been a lot of success there, definitely in California as well. But with the stations, there's now it changes every day, but there's about 20 stations, 14 that are actually officially public retail stations in California, another 6 that are open but not officially retail yet, and another total of about 52 now that are in the process. So the target for the end of 2015 was about 20 stations. The target for the end of this year, which is only 7-8 months away, is 50 stations, basically. So 100 stations by 2023. So obviously lots of focus in California. But I do want to mention that the northeastern states are also very, very interested. So we have Air Liquide here. Toyota, of course, has been involved. But there's interest in 12 specific stations in the Northeast also.
But aren't you a little bit concerned that you don't need the stations anymore if Tesla does the whole business over there?
Well, it's definitely a portfolio approach. So I think it's pretty well recognized that in terms of driving range and fueling time, that's where the fuel cell vehicles fit in. Obviously for a lot of stop and go traffic, shorter driving range, where you have the ability to charge over long periods. EVs make sense. So again, I think it's really a portfolio approach, but looking at the drive cycle, the duty cycle, if you need short driving range, small vehicles, BEVs, I think are a perfect niche. Longer range, you have plug-in hybrids or range extenders. Even longer range, obviously the fuel cell vehicles already on the road are capable of 300 miles. We actually validated a fuel cell vehicle that was capable of up to 430-mile range. And with just a few minutes of refueling, that's obviously a different market segment. So I think it's clear we need a portfolio of technologies if we're going to meet our climate reduction goals. Again, it's not either or. And so I would say the success with the EVs, any market introduction of new technologies has its lessons learned, and I think that's helpful for the fuel cell community as well.
But, Philippe, isn't that the lesson we could learn in Europe? This 18% of all newly registered cars will be zero emission. Would be a nice program for Europe, wouldn't it? Would help fuel cell cars very much. Yeah? Would you support that? You do a little bit of lobby work, don't you, also in Brussels?
I wouldn't say so. The Commission doesn't lobby the Parliament. We make proposals.
Okay,
but of course, there is something I could agree on. It's really that research alone or demonstration alone doesn't help changing the picture. We have to work on the regulatory framework. We have to work on regulations. Although the Commission doesn't make a choice between technologies, every technology has its own value. But we have to make sure that there are no barriers are created artificially that are preventing deploying this or this technology.
Brian, I know Dana produces bipolar plates, integrated seals and coatings for automotive fuel cells, and has struggled so successfully the issues of durability and costs, of course. Whatever you reach so far, you still need a hydrogen infrastructure, which is obviously built up now in California, but you need it all over the United States probably and all over the world. Actually, if you want to sell really your products at scale, and that's what you have to do. You can't sell just single products. You really need a scaled up product, haven't you?
That's correct. I was going to add, this is a bit of a tangent to your question, but one of the benefits of my company's perspective going back to 1904 is the fact that in those early days of the 20th century, there was a need to develop a gasoline fueling infrastructure. And although we don't have the same media coverage of that time, I'm sure it was just as challenging then, and we solved that problem. So I think that the evolution of a hydrogen fueling infrastructure will happen. The problems are not, the technical issues that will be overcome are being overcome. It's a matter of time.
Can I just add something?
Sure, go ahead.
To that. You know, consumers want to buy products that are great products. You have to provide a great product at the right cost. We make hydrogen. The deal with Toyota's at £10 a kilogram, which per mile is the same cost as petrol in the UK. Long run, when the loading of the station,
as long as not taxed.
That's today. When the loading of the stations goes up, we're looking at the EU target for hydrogen, which is £7 a kilogram, which is 20% less than diesel per mile. Okay, that's a straight cost advantage. The thing that would drive hydrogen cars is air quality. We've just been through Dieselgate in Europe, and everybody knows now that we have to clean our cities up. And you'll find driving a fossil fuel car will be like smoking in public. It won't take long.
Very good, very good.
But what I really wonder is if there's a real boom for fuel cell cars, are you ready to really produce at large scale? I mean, really large scale. Are you ready for that? Or do you have to build plants then and that will take another 5 years?
No, I think as a manufacturing company, we already have facilities for early production. We even have some manufacturing assets already in place that we can leverage. So the start of the commercialization is not a problem. In fact, we have some products already in early commercialization. Eventually, of course, as the volumes increase, then we will need to add equipment and facilities. But by then, there's a revenue stream coming in to cover that.
So Brian is ready. Graham is ready, Mr. Vannson, what we need is an infrastructure in Europe. And I think it's much easier to build up an infrastructure in Japan because nobody would think about driving from Tokyo to Shanghai, but in Europe it's like driving from Hanover to France, to Paris, or even to Rome. No problem. So we need an infrastructure all over Europe, which is quite a challenge, isn't it?
You should make the distinction between plants. There are plans, mandatory plans for recharging stations that are coming, optionally for hydrogen. But we are now supporting research and demonstration to prove the technology. We do a bit of stretching because we are, sometimes people would think we do not need 50 refueling stations to do the demonstration. But it's part of the plan. My feeling is that we, at some time, need to go to deployment. And deployment is not the appropriate instrument, is not the FCH. There are other means, the EIB, for example, but then you need a business case. You need to make the demonstration that there are clients waiting for refueling stations. And what we have to do, together with regions and member states, is to try to coordinate, to get the best of all the instruments that are in place.
So there's 3 very important FCHJU projects. High 5, which is 5 European cities, 5 OEMs. Yeah. Okay, we're building 3 refueling stations in London under High 5. Then H2ME, this is Hydrogen Mobility Europe, which includes a lot of European countries that have their own mobility programs all coming together. And now this year we're about to announce H2ME2, which is another very significant project. These are 30 million euro projects over 3 years. There's 100 million euros for hydrogen infrastructure in Europe, all coordinated together by the FCHJU. So it's been a fantastic job.
It is indeed. So are there any questions from your side? Just raise your hand if you have any question. I'll come right to you. Yes, that's the first one. Could you just approach a little bit so my way is not too far? And please introduce yourself.
Hi, my name is Don Drake from the U.S., and I have a question about the hydrogen infrastructure versus electric vehicles. People talk about electric vehicles and being able to plug in and so forth and so on, but taking a longer range view, what happens when there's 100,000 or a million or 10 million plug-in vehicles on the road, on the electric grid that's already at or near capacity, versus hydrogen stations that are easier to deploy? We're talking about short term. Where are we in 1, 2, 3 years, but 5 and 10 years down the road? For hydrogen, doesn't that make a better solution?
Don, it's a very good point. Look, if you plug in at home with an electric vehicle, you're plugging in between 6 and 8 o'clock in the evening when you get home. If you do that, you're actually charging your car with open cycle gas or peaking diesel. So that's the first point. Second point is that you plug into the low voltage network, which is all underground. Okay, if we have to reinforce the low voltage network, we have to dig up the roads. With hydrogen, you plug boxes like that in at the high voltage end of the 33 kV transformer, which is all overground, so it's very easy to enforce. In fact, in most European countries, the high voltage network has spare capacity, and it's the grid company that turn the boxes on and off, exporting the power when it's the right time to export it. In fact, we get paid to be available to be turned on and off. That's called grid balancing. So hydrogen gives you a managed export of energy from the grid, and plug-in electric vehicles don't.
If I can also add to that, if you look at a cents per mile basis, because a large station, whether it's gasoline or hydrogen, can service many hundreds of vehicles. So even though the capital cost is higher on a per vehicle basis, it can be just as equivalent to an EV, which basically has one charger. If it's a level 3 charger, it can be pretty expensive too, but which is servicing one vehicle at a time. So, but then again, the EVs are here, they're commercial, so they're already starting, especially in certain regions where you have high renewables, at least you are reducing total well-to-wheels emissions, getting some early technology, green technology into the market. So again, it's a portfolio approach, and each has pros and cons. Obviously, a widespread hydrogen infrastructure, when we're talking about pipelines and even large-scale delivery, that has its own challenges. So I think, again, there's no silver bullet. I think looking at the balanced approach and maybe a phased introduction of the different technologies is going to be valuable.
Any more questions from your side? I would like to focus a little bit on power to gas, because that's a big issue in Europe. Sunita, one of our exhibitors from Connecticut, Proton Onsite, is talking about megawatt scale energy storage in North America. Do you believe volatile energy sources like wind and sun will reach a large share in the US, even despite your shale gas boom?
Yeah, that's a great question. I think obviously, especially in Germany, we've seen a lot of interest because of curtailing renewables. So in the US, of course, we're not yet at that point in terms of market penetration, but in the last few years, we've actually seen huge increases of wind and solar. So wind is now about 4% of our grid. We've seen huge increases just since 2008 for solar, about 25 times the amount of solar as in 2008. And there are actually certain regions in the U.S., the Northwest, for example, Pacific Northwest, where they are curtailing, Texas as well. So I think that's where hydrogen can come into play, not just for energy storage. So we're looking at hydrogen at scale, so power to gas. Obviously, with low-cost natural gas, we're not that interested in synthetic natural gas, but using curtailed renewables with electrolysis, so we can get down in cost for the hydrogen, either injecting that hydrogen into the natural gas pipeline as a storage means, or using that hydrogen. Obviously, the vehicle demand is not there quite yet, so eventually we could use that hydrogen for fuel, so a one-way storage approach, or we could actually use that hydrogen for multiple ammonia synthesis, fertilizer, petroleum refining, even metals production, refining, and actually, if you look at the total global greenhouse gas reduction or greenhouse gas emissions in the metals refining production industry, it's almost 10% of global greenhouse gas reduction. So I think there are a lot of valuable market opportunities for hydrogen, the whole hydrogen at scale concept, so it can decouple, as opposed to just electrons to electrons with conventional battery storage, electrons to hydrogen as a carrier provides a lot of opportunities. So we're just starting to look at that. But again, I think a key driver is going to be once we get to significant penetration of renewables, so we're starting to see curtailment. I think that's what will drive the hydrogen market.
And Philippe, another big issue in Europe is also decentralized power generation, and also micro CHP could play an important role in private homes. For this Underfield project is very strong in Europe. How far are you there?
Yeah, there are different issues. There are different debates. If you look into the so-called energy transition, Energiewende, there, for example, the debate centralization, decentralization. There are also the debate how could we integrate as much as variable energy as possible. In this respect, I mean, you mentioned Underfield. Whatever solution, even if we use natural gas, there is a net gain on the efficiency. That shouldn't be neglected. Of course, cost, it must be economical, and cost must decrease, and we need some scaling up. We need to produce more, to install more units. There is also one issue, I mentioned the regulations. CHP are penalized by the so-called eco-labeling because they are, the matrix used by directives is not referring to the electricity produced. And there is certainly something to work on.
This Underfield project wants to install 1,000 new installations in 12 key member states. But they are testing these micro CHP already since 1998, and it's funded since 1998. So after 18 years, wouldn't it be sometime an end to funding? What do you think?
I think there is no end to research and development. What is important is market penetration. And we have to do the demonstration that it works, that cost can be decreased, and the only solution is to do the demonstration. Partners tell us that they will be able to decrease cost if we increase the number of units.
Brian, you're also producing hydrogen reformer products for generating in situ hydrogen fuel. That would probably also fit to a micro CHP device. I don't know if you're thinking in that direction, but in the United States, as far as I know, there's no micro CHP manufacturer there, is it?
That's correct, outside of Japan at least. That certainly is a market segment for the small reformers that we are working on. And incidentally, we're not making the whole reformer, we're making components of the reformer. Again, we're leveraging what we know how to do to help our customers develop what they need. But you're right, micro CHP market, as well as telecommunications, backup power, those are all market segments for in situ hydrogen reformers.
Graham, did you want to contribute?
I was just going to say, the reason you do embedded generation at all is to bring heat into buildings or houses. Okay, that means that you get a more energy efficient generation because you're also providing heat. Renewable heat is the most difficult thing to decarbonise. Electricity and transport are relatively easy in comparison with heat. The best way of decarbonising heat is power to gas. Okay, you take renewable power that is in excess that you may curtail. you make a renewable gas with it, and you put it straight into the gas grid. And most gas grids around Europe, 60% of that gas goes to making heat. So actually, power to gas is energy storage and the provision of renewable heat.
We have renewable gas in the end, so it can take a larger and larger part in the gas grid of the renewable gas.
So this embedded generation project using solid oxide fuel cells is one way of doing it, increases the efficiency of generation. The other way of doing it is on a mass scale, where you don't even involve the consumer, you just centrally inject hydrogen and you make the decarbonisation, and then whatever the gas touches, it is decarbonised.
So I think I could summarize there's a lot of work already done in the United States and also in Europe. It's still a lot to be done, still a lot to drop the costs down especially, and make the technology more durable. We have reached a lot of that in that direction already, but there's still a long way to go, and we should probably best go them together, and maybe that we take as a summary of this discussion. I thank you very much for your participation here on stage, and I thank you very much for your attention.
Thank you.
Our next interview on stage will be with Alexander Dauensteiner, Head of Product Management System Products of Weiland, about the market launch of the Weiland fuel cell for the single family house. So please stay tuned.